Swayam Prabha. Digital India. Educated India.
Welcome, good morning. Welcome to this course on comprehensive view of speech processing. So, today will be the second lecture. So, in lecture 1, we covered some introductory part related to speech processing, and in this lecture we will continue with the remaining part of introduction related to speech processing, and we also try to introduce a topic on speech production and perception from a human perspective and all. So, in the lecture 1 we covered about very briefly about like what is first of all we try to define the speech, and then we try to define a more focused on definition of a speech by associating a language to that. And then afterwards we also try to emphasize what do you mean by the speech processing, and what is speech processing or what is not speech processing. So, that kind of a discrimination we will try to introduce in the discussion related to the speech processing. And prior to that we also mentioned that the speech processing course had wider applications, applications in various fields across various disciplines and all. So, that way in that context, because as we have defined, the speech processing is nothing but providing speech interface to the machines, and as machines are there in different fields. So, therefore, the applications related to speech processing or the area of speech processing or the research area of speech processing can be catered to multiple disciplines and all. So, in that context we discussed about how various disciplines will contribute to speech processing. So, we discussed about different disciplines and its contribution towards speech processing. So, those aspects we discussed, and afterwards we discussed about try to define the speech more precisely by associating language to the speech. And then since the language is associated to speech, so the language constraints also tries to bound the speech within language permissible limits and all. Then afterwards we discussed about what do you mean by speech processing. So, from a human perspective, what is speech processing, and from a machine perspective, what is speech processing. So, that way we try to introduce the terminology related to speech understanding, speech recognition, speech generation, speech synthesis, and so on. So, these are because speech understanding and speech generation or speech recognition or speech synthesis. So, this terminology is very much related to a speech processing that is related to a machine and all. So, those terminology we introduced, and we also mentioned how what do you mean by speech recognition. With a simple block diagram we discussed about how the speech recognition will takes place. It is nothing but speech understanding from a machine counterpart, and the same way how the speech can be synthesized or the speech can be generated from a machine, and so that is also known to be text to speech synthesis. So, this also we discussed with a schematic block diagram and all. So, then after discussing about what do you mean by speech processing, why speech processing is required, then we move on to the applications of speech processing. So, in that we first mentioned about an application of speech to speech translation or speech to speech conversion. So, in that we introduced a simple block diagram to explain how the speech to speech conversion will take place. So, in that we mentioned about the speech to speech conversion is nothing but speech of a given language from a given language, like from a given for example, speech of English will be transformed or will be converted to speech of a German or speech of a Hindi, like we are providing the same message out of that. So, for that we require both speech understanding as well as the speech generation is also required. In addition to these two, here we are converting a speech from one language to other language. We also need the message transformation from one language to other language. So, that is from English to German or English to Hindi or like whatever, from one language to other language, the message content has to be translated properly and all. So, for that we require the need of the natural language processing also. So, therefore, the speech to speech conversion involves both the speech understanding and speech generation, and as well as natural language module, natural language processing is also required and all. And it has very huge potential of applications, like as I mentioned, like in the case of United Nations meetings and all, where across the globe all the countries, the heads of all countries will assemble or will meet to discuss on some topics which are common across the world. So, in that case, this speech to speech conversion application will play a very important role, and it very seamlessly can able to the meetings can able to happen. A person can from any language he can speaks based on his interest, and the same content will be delivered to all the people whoever is there in the meeting and all in their respective languages and all. So, that is very important application. In addition to that, there are some very common applications like for example, in case of traveling, when you are traveling to countries where you doesn't know the language of that particular country. So, in that case, if you want to have any conversation or any business like in the tourism also. So, likewise in these applications we need to have a speech to speech conversion will play a very important role, and particularly countries like India, where we have multilingual country. So, where we have geographically we have several languages people speak from in the different geographical areas and all. Like just if you move from one place to about 200-300 kilometers, you find people who are speaking some other language and all. So, likewise in India we have about officially around 24 languages, and we have several hundreds and thousands of languages people are speaking. So, therefore, if you want to have a conversation, if you want to have a business, if you want to have any information transmission, information communication between the people, so it's better to have a speech to speech conversion which can able to solve lots of problems and all. So, that is a very fundamental application based on speech processing. In addition to that, we have here I just mentioned other applications. Like for example, here whereas the speech to speech conversion involves both speech understanding as well as speech generation, and here each of the individual tasks or individual task related to speech understanding or speech recognition had its own applications, right. And here if you look at here in case of speech recognition, so here we have application like as I mentioned that to have a speech interface to machine, we require both speech understanding or speech recognition task has to be performed, and as well we need to perform a speech generation or speech synthesis task also. So, in that context here the speech recognition task will be useful or will be required to perform an application of speaking interface to machines and all. Like in case of speaking interface, we require both speech understanding, speech recognition as well as speech generation. So, therefore, here it provides you the one way communication. As a human speaks, the machine understands that particular speech. In that respect, the speech recognition is required, because basically from a machine counterpart or machine perspective, speech recognition is nothing but deriving the text from the speech, given speech, because the speech will be generated by humans and the text will be interpreted, text will be generated by a machine from the speech. So, that way it has an application in speech interface with machines. And another application like the automatic dictation system. So, this is most of us familiar, because this application has a versatile role in the different fields like any organization or any institution and all, and you need to have like send the letters or send the information to the other to for some other application, some other task. So, in that case where if you have a proper speech recognition system which can able to provide you the automatic dictation system, so with that we can able to avoid a need of humans to note down the letter, note down the content, and again typing and again sending to the desired destination and all. So, that way this automatic dictation system will be very useful. It avoids the human intervention for taking a notes and then later on preparing a letter and deliver to the desired destination and all. right? And similarly in healthcare applications also the speech recognition will play a role, is required, because in case of healthcare, because in case of hospital management system and all, where the doctor and the patient, they will interact, the patient doctor interacts with the patient, and patients will tell the symptoms and other thing, the doctor will again poke some questions and he will respond to that. So all these things you can able to, like by using speech recognition, you can derive the text out of that, and then you can able to process further to prepare the patient history, and it can be used further for the hospital management system and all. So not only that, in the case of healthcare, for there are other issues like, for example, if there is any problem in the our pathological system related to the speech, like in the speech production system, either in oral cavity or like in case of lungs and other windpipe and so on, if there are any issues, any health issues and all, so those things also you can able to like you can able to detect with the help of speech recognition and all, because we know that the speech recognition for a normal person or for a healthy person, how it looks like, and if you monitor, if you analyze the speech of a person who had a problem with some vocal disorders or something, so with that you can able to discriminate a person having healthy person versus the person having the different disorders and so on. So that way the speech recognition had several applications. Here I have just mentioned a few important ones and all. And a speech synthesis is nothing but a speech generation from a machine perspective, and as I mentioned that here it also play a role in speaking interface with the machines and all. As I mentioned that a speaking interface constitutes both speech understanding as well as speech generation. So that way speech synthesis is also a part of providing interface to the machines, and with that you can able to generate a voice response system, and using a speech synthesis can be useful for the applications related to screen readers, reading story books and so on. And basically these applications whatever I have just mentioned over here, the screen reader and reading story books and so on, so they are very helpful for the visually challenged people and all. For visually challenged people, one important application based on the speech synthesis will be, so using the speech synthesis they can able to, that means using a speech generation module, the visually challenged people, they can able to interact with the machines, interact with the computer. Suppose a computer normal, we can interact with the computer using a keyboard and so on by entering the commands or whatever, we can do that, or a mouse and all. But whereas for visually challenged people, they doesn't know what's there on the screen, how to start and how to proceed, how to progress, how to like perform various tasks on a computer. So for them the speech synthesis will be. So here the visually challenged people, by using a screen reader, so they can use the mouse and then they can traverse through various and then when you place the mouse at the icon, then the speech will be generated corresponds to that icon. So with that the visual challenged people, they come to know that whether they want to access that or otherwise they want to move. They can also use the menu driven. So the screen readers will be highly useful for the visually challenged people, as I mentioned that. So the visually challenged people, if they want to interact with machine or if they want to use the machine like other humans, so these speech synthesis systems will be very useful. So they can able to speak out based on the mouse placements and all. So with that they can able to access the computer, they can able to access the information through computer for various applications and all. And here as I mentioned here, in the case of speech recognition, so even our students, our research students, they developed an application related to one of the sponsored project. Here this interface using speech recognition, they developed an interface where with which the agriculture farmers, they can able to they come to know, they want to know the price of the grains which they have they grown. In that context, by using a speech recognition, we developed a system, a prototype system, with which the farmers, they can interact or they can able to call the mandis in their local region, and they can able to check that what is the price of a particular grain, and if they like the price they can able to sell it out, otherwise they will keep the grains for further after a month or after a week they can again check it out. So that way they can directly interact with the mandis using this system. So for that here we have a limited domain speech recognition is required. So because here in this context the farmers they can able to ask the price of grain, and here the number of grains or the varieties of grains are there are limited, and the mandis in their local place is also very limited and all. So that way by using like interactive system, speech interactive system, the farmers can able to directly contact the mandis with their mobile phone, and they can come to know the price there in their local markets. So with that they can without interference of other humans, the people, they can directly in contact with the mandis, local markets, and they know the price, and with that based on their interest they can able to sell their grains whenever they want. So such a system we have developed in 12 Indian languages and all, whereas the IIT Kharagpur we developed a system for Bihari Hindi. And the same way here also, based on the speech synthesis also, we developed a system for a screen reader for visually challenged people in a Bengali language, and we developed this system, and this system works for both bilingual, it means both Bengali as well as English also. And the developed system is also demonstrated in Calcutta, the center visually challenged people where they are there, and we conducted a workshop for 2 months, and we trained the people, the visually challenged people, like how to use the developed system for accessing the computers and all. And a combination of these two, the speech recognition and speech synthesis, we have used to develop a product known to be form filling application and all. So this is an interactive system, form filling application, because if you go to any enterprise or any organization or any government organization, so the first thing that need to be performed is that we need to fill up a form, and in that based on the task we need to fill up the different information. For example, if you want to like reserve a ticket, train ticket and all, so we need to fill up the form. We need to provide the railway stations, from where to where we have to go, from which date we have to go, what class you have to go, and what's your name. So there are several fields that used to be filled up, and then the system will we have to feed that information to the system, and the system based on the availability it responds back. So likewise we have several applications, like for example in case of Aadhaar registration and all, we need to fill up some certain details and all. So that way we generated some generic form filling application which involves both speech recognition as well as speech synthesis and all. That means for providing the information, we make use of speech recognition, and with that whatever the information that need to be provided, so that will be given in the form of through speech mode, and the machine will derive the text out of that, and again it just spells back, it again speaks back to the person to verify that whether the content that was derived, whether it's correct or not. So that way by using back and forth, by using speech recognition as well as speech synthesis, one can able to fill the forms automatically using the speech mode from your mobile itself. You need not go to the place, you need not go to the railway station, or you need not go to anywhere or any other center and all for filling the forms and all. You can able to do it right away from your mobile itself using the speech mode and all. Right. So that way we have an application that was derived as a part of a sponsored project sponsored by the MIT Government of India. By combination of these two tasks, speech recognition as well as speech synthesis, we have carried out that one. And there is other speech task that is related to speaker recognition and verification. Using this particular speech task, we have the applications that are related to the security. So here you can see that the voice based person authentication system. So here like it has application in several fields, like for example in the banking sector we have application, and even airports or in the different places where wherever there is some entry, authenticated or secured entry is required, you can use the speech modality as a biometric for personal authentication and all. You have other biometrics like a fingerprint or the facial face verification and so on. Along with that, you can also use the speech mode of personal authentication, which will add the more authenticity along with the other authentication modes and all. And it has also application in the forensic investigation also. So, in case of forensic investigation application, so you have the speech samples of the available or known terrorists and all. So, if you have some new speech sample, if you want to check whether that speech sample corresponds to any of the existing terrorists and all, so you can able to, by matching with the existing speech samples, you can able to verify that whether this speech is produced by or is it from any of the terrorists or not. So, for in that way the forensic applications also can use the speech recognition or speaker verification and all. Right. So, the next there are other applications like based on the language identification task. Here the task, the applications related to language identification task is nothing. This is kind of a front end for most of the speech systems and all. Basically, in case of speech understanding, the language identification will be the first task that will be performed. So, with that we will come to know that this speech corresponds to a certain language, maybe English or French or so on. And once you identify the language, once you know that the speech corresponds to a specific language, and then the knowledge of the language model is required for deriving the text and all. So, therefore, for a speech like understanding or a speech recognition application, we need to have a language identification module or language identification is required at the very front end. So, that once we know the language of the given speech sample, then we make use of that particular language model. Language model is nothing but the pronunciation dictionary and the other information related to a language that is required, that will be used for deriving the text, deriving the words of a particular language and all. Because as we have seen that in a speech understanding, the first module will be like acoustic model. So, that derives the sound units, a sequence of sound units from the speech signal and all. And from the sequence of sound units, once you know that the language of this particular speech, then by using the appropriate language model, is nothing but the pronunciation dictionary of that language, then we can able to validate and then we can able to derive the words associated to the language and all. So, in that context the language identification is required. Then the information retrieval, as we have seen, the present information, the most of the present information is in the form of either audio or video, multimedia form and all. So, in that case, as we have seen in our day to day life also, there are lots of news channels, lots of the channels, audio channels in our local language and all. So, that way we have a lot of data is keep on piling up, and if you want to properly make use of the data at a later point of time for any queries, for any other issues and all. So, you need to properly organize the data, right? You need to properly organize the data, store the data, and then afterwards, so whenever there is any query in view of that particular repository or particular data, so we can make use of this organized data, then we can able to retrieve it properly and all. So, that way the information retrieval purpose also we need to have the speech processing is required, because if the data is audio data or a speech data, then first of all you have to store it in a very systematic way, and then afterwards you have to index the data, so that by using the indexed data later on, if there are any queries were there, and you can make use of that index data, index structure, you can retrieve the desired speech documents very effectively and all. So, that way we need to have this speech that means speech processing is required in this context and all, right. Again, there are different ways to like organize the data or retrieve the data. There are by using supervised and unsupervised approaches one can able to do that, but we will discuss those details later on as we know a little bit more about the other details. We will discuss about those things. Then the speech enhancement, this particular task is required, is required for varieties of applications, because this from the name here, speech enhancements, here will try to enhance the speech, right. So, here normally the speech, the whatever that will be used for various speech tasks or for speech applications, the speech is not collected from the very clean, not from the like very clean speech and all. That means, it is not that always it's not possible to collect a speech, good quality speech, by keeping a microphone very close to the mouth, and that kind of a speech is not expected for most of the applications and all, because as a person, because the speech here, all these speech tasks or speech processing is required for the machines, because we want to interact with the machines and we want to interact with various systems and all. So, therefore, it is not, we can't expect that all the time we will speak to a machine in a very controlled environment and all. Sometimes you may be in a room, or sometimes you may be in outside, there is a lot of wind may be blowing, and sometimes you may be in a crowded places, like in a railway stations, or in a cafeteria, or in some other places and all. So what I want to convey is that actually here the speech applications, whatever I just mentioned, so we can't expect the speech that can be used for various applications, cannot expect it's a very clean speech and all. So, because of different environments are different, locations are different kinds of places where we will encounter from time to time. So, therefore, we expect the speech will be considered with the different backgrounds and all. Sometimes we may have a clean speech, sometimes we may have a speech from various environments and all. But the most of the speech applications, whatever we develop, we used to develop with a clean speech and all. So, therefore, when we use this speech from different background or different environments, when you apply to the speech applications that are developed, then that application will not perform proper and all, because that application, suppose for example, you build a speech recognition system for a form filling application or whatever, and in that case, for building the system, we might have used the system, we might have used the speech, a very clean speech, right. And when you are testing, or when you are in the application, when you deploy the system in the practical scenario, where at that time the speech, when you are giving a speech where the speech may be noisy, the speech may have with a different background, right. So, in that case, when you give that speech input to the application and all, then the application will not perform proper. So, therefore, they should have like a speech enhancement task need to be performed. It means that the goal of a speech enhancement is nothing but, so the speech enhancement task will perform convert the noisy speech to clean speech and all. Noisy speech to clean speech. So, noisy speech means the speech that is encountered, a speech that will be collected from different backgrounds, maybe room environment, maybe outside, maybe indoors, or maybe in some suppose in a room under the fan you are there and you are collecting, you are talking, for example. At that case, the speech will be like a background with a fan noise will be there, right. And so, that way the speech from a different backgrounds where that need to be cleaned up for performing various applications. In that context, the speech enhancement application is very much required and all. So, we need to like figure it out, what are the speech characteristics, what will be the other background environment characteristics and all. So, by knowing that, then one can able to figure it out, where are the speech component, how to highlight the speech component in presence of the background, so that the speech will be emphasized, the speech can be enhanced and all. You can use that enhanced speech for the later applications. And the same way we have the applications related to speech coding. So, here the speech coding applications means actually this is basically used for speech transmission, the applications where the speech transmission is involved. In that case, the speech coding will be task is required and all. Speech coding means actually the speech signal, whatever is collected through microphone, and so that will be, you have to code somehow with appropriate coding techniques, so that the coded information will be transmitted through channel, through either through internet or through various channels, that depending on the application and all. And at the destination, at the receiving side, from this coded speech to again decode, and again you have to regenerate the speech back, you have to reconstruct the speech back. So, here in case of speech coding, the idea here is that, so how do you efficiently code the speech signal and all? How do you efficiently code the speech signal so that at the destination you can able to recover the speech back without any loss of information and all, right. So, here again we have different constraints will be there. So, when you are coding the speech and all, so you have to see that the speech that is coded will be bandwidth efficient and all. So, with that actually we can effectively utilize the channel bandwidth, so that we can sometimes there are channels where there are bandwidth constraint channels used to be there. So, at that time if you effectively code the signal, if you effectively compress the speech effectively without loss of information, that will be highly useful, highly required and all. And sometimes at some places, some environments where you have resources are a constraint, for example, in case of IoT or in case of sensor networks or wireless ad hoc networks and all. So, there are some other requirements used to be there. In that context, how do we code effectively so that we can reconstruct the speech without any loss of information. And you may be wonder all these speech processing tasks, whatever they are evolved, and what are the speech processing techniques that were evolved. So, they are first initiated with the speech coding application, because you can see that the speech coding means basically telephonic application. So, at the line telephony, that means in 1960s, 50s, 60s, and it is very popular. So, that time at that time there are other speech applications were not there. That means at that time there is no mobile phones, and even the computers also not very much used by humans that time. The computers are used, but they are used for scientific applications. Mostly researchers they have access to the computer, they use it for only for scientific applications, scientific computing, not for the personal level. So, therefore, at that time the only application that is based on the speech is a very high demand is the telephonic application. At that time the telephones are come, with that the people can able to speak from different places through our normal line telephony and all. So, at that time the bandwidth is very important, right. So, that context here in 1960s, 50s and even 70s also, most of the speech research is hovered around the application of speech coding and all. Speech coding, and whatever the techniques that were developed in the context of speech coding, that is nothing but to have a speech signal, we have to parameterize, we have to encode this speech signal such a way that at the destination or the receiving side we have to recover it without any loss of information and all. And those techniques are used even in the speech processing application, like even in the speech recognition or even the language identification, speaker recognition also. People use the techniques whatever is developed in the speech coding, they have been used, because in case of speech coding one important thing is that the speech has to be parameterized. That means from the speech they derive the feature vectors, and that will be used for transmission, and later on that the same from those parameters we have to recover the speech. And at that time the only application is the speech transmission. There is no other application like speech understanding or speech synthesis. So, those are not required at that time, they are not available, they are not targeted applications. But later when these applications are required in late 70s or 80s or 90s, at that time people started using, people explored the techniques that have been developed for speech coding have been used again for the speech understanding and speech synthesis also, and language identification and so on. Right. So, that way the speech coding now it is not almost it is like a kind of a solved problem, but during 60s and 70s and all, the only application, the speech application that is very rigorously researched is the speech coding and all. And the last one I just mentioned over here is a paralinguistic analysis. So, it means here the speech signal, as already we are aware that the speech signal it carries several informations, like one is the basic one, the message that is present in a speech, and the speaker specific information, language specific information. So, along with that there are other information, like from a speech signal one can able to analyze that what is the emotional state or what is the emotional content in that particular message and all, right. Whether that emotion or the content is related to like anger emotion, or it's a neutral, or like sad emotion or happy content. So, all this information also that is there embedded in the speech signal and all. So, by processing a speech signal, one can able to identify that what is the message content, is which emotional content the message is related to, right. So, by using emotion recognition, one can able to analyze that the speech content or the message content that is embedded in the speech belongs to which emotion, right. And likewise the speaker style and the pronunciation and speaking rate. So, all these things are also there are not to be paralinguistic information. It means that what do you mean, the meaning of the paralinguistic means the speech, when you transcribe the speech into the message form, in the text form, the text may not convey the emotional content. The text may not convey the emotional content. The text will basically convey the message part. Sometimes with appropriate words you can able to make out that whether this message is corresponds to any happy message or like anger one or like a sad one. We can able to make out to some extent, but it is not complete. Whereas if you have a proper emotion recognition system from a speech directly, then based on the way it was uttered, one can able to make out that speech content is related to a particular emotion and all, right. And likewise along with the speech there is other information like speaker style, because some speakers they speak faster, some speakers they speak certain words with a stressed one, some speakers based on their native language, when they speak the foreign languages their accent will be different. So, all this information is nothing but known to be paralinguistic. There is nothing to do with the text, the message and all. So, there are known to be paralinguistic information, and the paralinguistic analysis will be useful for various speech tasks and all speech applications. So, next we move on to the develop these applications. So, for just we have mentioned that how the various speech tasks will be used for developing the various applications, right. And now we will see that how do we develop these applications. So, whatever the application speech application need to be developed, it is a combination of the following tasks, whether it will be involved with the speech recognition, or it may be involved with the speech generation, or it may be like a speaker recognition or verification, or language identification, or like a speech coding or speech enhancement. So, whatever the application related to speech, so it will be like one or other combinations of these basic speech tasks and all. To perform a speech application that is related to speech recognition, here the objective is that from the speech we need to derive a sound units, a sequence of sound units. Yeah, here the case of speech recognition, the task is that from the speech signal we need to derive the sound units first, and afterwards from the sequence of sound units we need to derive the text or we need to derive the words. So, therefore, the objective of speech recognition is that from the speech signal we need to derive or we need to detect the sound units that are present in the speech signal and all, right. And in case of for example speaker recognition, here the task is that from the speech signal we need to find out who has spoken that means the identity of the speaker. So, here in case of speaker recognition we are not interested in what he has spoken, like here the task is that in case of speaker recognition or speaker verification, the task is that from the given speech sample, so we need to like tell or we need to find out who has spoken that, who is the speaker, right, or we need to verify that whether this speech utterance is spoken by a person X or not. So, that was the task related to speech recognition or speaker verification, right. In case of language identification, the objective is that, so from the given speech signal we need to detect or we need to identify that which language this particular speech utterance belongs to, whether the speech utterance belongs to English language or Hindi language or some other language. So, that way here whatever I just want to mention here is that there are different speech tasks, the objectives are different, but the input remains same, but all the objectives need to be carried out or need to be performed or need to be carried out from the speech signal itself. That means the input remains same, the input will be a speech signal, but as per the task the objectives are different. So, therefore, to carry out all these various applications, so from the speech signal we need to derive a specific features that are related to the given task, that are related to a given task. For example, if our objective or task is speech recognition, then we need to extract the features which signify the sound units, which characterize the sound units and all, right. So, there we are not bothered about who has spoken that, what is the speaker style, what emotion it contains, those are not important. In case of speech recognition, so we need to identify the features, or we need to derive the features from the speech signal which try to emphasize, which are mainly characterize the sound units. So, such features has to be brought out, such features has to be used, to be identified, to be extracted from the speech signal, and those features will be used later for to identify to detect the sound units that are present in the speech signal and all. So, the same way in case of speaker recognition, here we need to figure it out, or here we need to extract the features, and those features should highlight or should basically emphasize the speaker style or the speaker related information and all, right. So, therefore, in case of speaker recognition or speaker verification, so we should identify the features, or we should make use of the features which basically characterize the speaker information, speaker related information. So, the same way for the language identification also, in case of language identification also. So, from a language identification perspective, so from the speech signal we need to derive the information which signify the language content or the language identity and all. So, the same way for a speech coding, for example. So, when you are in the speech coding related application, the features that are required will be, so in the encoding process we need to derive the features. So, those features, the features that are derived in the encoding process should be useful or should be very much required. At the time of reconstruction, we need to get back the same speech signal, whatever is encoded at the transmitter side. So, that way in case of speech coding application, the features that need to be properly encoded, so that they should be robust enough to transmit through various channels, and at the given target, at the given destination, we need to recover, we need to reconstruct the speech back without any loss of information, right. And then come to the speech enhancement. Here the task is that, because we know that in case of speech enhancement, the input speech will be a noisy speech. It means noisy means what I mean to say is that it's not a clean speech. The speech that is embedded with the different environmental information. That environment, that may be, for example, maybe some other speaker also there. Suppose there are multiple speakers were there. There are a group of people are there. They are talking. They are speaking. So, in that case, actually, suppose there are 4 people, they are speaking, and if you keep a microphone, then the microphone will capture the speech of all the speakers and all. But our target application will be a speech of, from this mixed speech, or from this speech we need to derive, or we need to emphasize a particular speaker's speech or particular speaker's speech content and all. So, in that case we need to de-emphasize the remaining speakers, so that the particular speaker, the target speaker's speech content will be enhanced and all. So, that way, otherwise sometimes suppose the speech you have collected in a crowded environment or in railway platforms. So, where we have a different noise will be there, lot of background noise will be there, maybe the train horns or different noise sources will be added to the actual speech content. So, in that case our target is that, so whatever the speech content is there, that has to be enhanced, and the remaining noise content or a noise related characteristics should be de-emphasized and all. So, therefore, in case of speech enhancement application, where we need to identify the features, or we need to extract the features that are, which basically characterize the speech, and they should discriminate the non-speech, the noise, reverberation and all. That means, here we need to characterize from the noisy speech, we need to characterize the speech, non-speech, and we have to, that means basically the features that are extracted from a noisy speech will be, they can able to discriminate the speech versus the other components of that are embedded in the noisy speech, like the pauses and the noise and the reverberation and so on. So, once you have characterized all these components, then we will try to emphasize the desired component, that is the speech component, so that the other features, other related information will be like once you are like emphasized, then other information will be automatically de-emphasized with respect to the specific component. And so, that way we can able to enhance the speech with respect to the noisy background and all. Because all the speech applications, we do not expect the clean speech input, right. So, therefore, as I mentioned, like the way the language identification as a front end, the speech enhancement is also used as a front end, like as a pre-processing task before feeding the actual features to the targeted application and all. Like first of all, we clean the speech, we enhance the speech, right, or the whatever the noise that is associated with speech will be removed or will be de-emphasized, and with that we will try to like generate the clean speech out of that, and from that the features will be extracted and that will be used for various speech applications. So, that way what I want to mention here is that for developing speech applications, so because all we need to carry out one of these or like combination of these speech tasks and all, and to perform these speech tasks the input will be the only speech signal and it carries all the information, like it embeds all the information, and to perform the various different specific speech application. So, we need to extract the features that are related or that are targeted to that particular application, as I mentioned earlier and all. Yeah, in view of this, so far we discussed about speech processing and how it is different for humans and machines, and what are the like applications of speech processing and how do you develop these applications and all. So, in that case, in that way we will come to know that actually we need to extract the features from a speech signal to build the models or to perform various speech tasks and all. So, to learn all these things or to understand or to learn to capture all the detail, all the things whatever we have discussed so far, for that purpose, in that view we designed the course as 4 parts, the introductory and acoustic phonetics, where it gives you the providing the introductory to the speech processing, and then coming to the acoustic phonetics and all. Here we discuss about what will be the speech production and perception mechanisms in view of humans, and then how do we expect or how do you mimic the machine to perform a similar task and all. So, in that context one should aware of that, first of all, how humans perform a speech production and speech perception, right. We will try to understand to some extent, and afterward these speech production and perception mechanisms, how they are like reflected in the speech signal and all, because when the speech produced by human, it is emitted as acoustic variations and acoustic pressure variations. So, in that speech signal, whatever I just mentioned, suppose there are different sound units, they are uttered in a different with a different constraints and all, how those constraints and how those events are reflected in the speech signal, and those things we discuss in the acoustic phonetics. It means that in the acoustic signal, how we will try to observe the various manifestations of the sound units and all, right. For each production of each sound unit with the different manifestations of the different articulatory movements, a particular sound unit will be generated and all, and we will try to see that how those the manifestations in the production mechanism, how they are reflected or how they are manifested in the acoustic signal. So, those things we will try to discuss in the acoustic phonetics and all. That means, for each phoneme, how the acoustic signal will be, and the properties of these various sound units, how they are present and how they are reflected in the acoustic signal, and so how do we observe that, because this acoustic signal we know that it is a pressure variations, but if you want to observe that, we will try to like represent that in the electrical form by using a mic, and afterwards we will try to display that in a time domain, or will by using in the transform domain, we will try to visualize this signal, acoustic signal, in different transform domain and all, either in the frequency domain or in some other domain. So, all these details we will try to look into in the acoustic phonetics and all, because these are very important, because based on how the production concepts or production mechanisms, how they are reflected, how they are present in the signal, because from that only the machine should able to derive the text out of that, they able to derive the sound units, they able to detect the sound units and all. So, therefore, the acoustic phonetics are very fundamentals and they are very much useful for designing the various systems and all, or to identify that what features are important. For all of them, understanding of acoustic phonetics are very important. So, then after knowing these, the introduction to the speech processing and acoustic phonetics of related to speech, then we will try to discuss about speech signal processing and analysis methods. So, here this is a slightly broader topic. Speech signal processing means actually here the speech signal is a acoustic signal and we cannot handle that directly by machines and all. So, therefore, that will be converted to appropriate form using electrical in electrical form using a mic, and afterward that is analog signal, but still the analog signal cannot be handled by machines. So, therefore, it will be properly converted to digital form by using appropriate A to D converters and all or coding techniques. Then afterwards, we need to see that, as I mentioned, that by knowing the acoustic phonetics, we know that how these signal manifests various events related to various sound units and all. So, all of them will be analyzed or observed by using appropriate analysis methods and all. First of all, for signal processing methods, we will try to visualize the signal either in time domain or frequency domain or in some other transform domains and all. So, therefore, we need to have different signal processing techniques has to be analyzed or can be learned, and with that we can able to process the speech signal, and then afterwards we need to analyze the speech signal in view of this acoustic phonetics whatever we studied and all, because those are required. We need to discriminate the sounds, or we need to discriminate the various speakers, or we need to discriminate the various languages and all. So, therefore, by analyzing the speech signal we will come to know that which features are relevant for speech recognition and which features are relevant for speaker recognition and which are relevant for language identification and so on. So, that way these speech signal processing and analysis methods are useful for like analyzing the speech signal or extracting the relevant features from the speech signal. So, that way these speech signal processing and analysis methods are useful or required and all. So, once we cover these things, speech signal processing and analysis methods, so we will go to the speech modeling techniques, because our ultimate goal is nothing but our speech, the application of the speech task is nothing but we need to provide either a speech recognition or a language identification or speaker recognition and so on, right. So, therefore, for that by using the speech signal processing and analysis methods, we extracted the various speech features and all, and by using those speech features we will try to model, will develop the models, speech models, so that by using speech models we can able to perform various tasks. Suppose we will develop a speech models corresponds to speech recognition. So, here the model should discriminate the different sound units, because there are 50 sounds for example. In that case, so the features that are derived by using analysis methods are be used. With that we can develop a model where that model can able to discriminate between across these 50 sounds, right. So, with this model we can able to derive the sound units and all. So, that way these modeling techniques, the speech modeling techniques we will study, we will discuss about that with different modeling techniques, and for these modeling techniques we need the input from the analysis methods and signal processing methods and all, because from that we will derive the features and we use those features and we will develop the models and all, which can able to discriminate different sounds or different speakers, or like languages, or like discriminate the speech versus noise. So, all these tasks can be performed by using the modeling techniques and all. And then once the modeling techniques are developed, then we can make use of these modeling techniques for developing speech systems, because the speech systems are nothing but integrating the different things whatever we have done, the speech models, and again the feature extraction techniques, and all of them will be properly integrated, so that we can able to develop a prototype system which can able to deploy later after properly verifying the system and all. So, under the speech systems we will discuss about the various prototype systems that can be developed with the help of the modeling techniques and the feature extraction methods and so on. So, then this is like a broader picture of the scope of the course, or like the contents, and for details, the detailed contents are shown in this slide. So, we will continue this in the next lecture. So, at this point we will stop here.
This course is a comprehensive view of speech processing, and this consists of 40 video lectures. For each video lecture, the contents that to be covered in this lecture are listed in a slide, and that slide will be displayed at the beginning of a video lecture for about 10 to 20 seconds. The contents with the words and phrases of these contents can be viewed as keywords, and with which you can able to access the desired the video lectures or the part of the video lectures by using these keywords.